Walk forward. Turn 180 degrees. Walk forward halfway, stop. Turn left 90 degrees. Welcome to day 11 of the 12 Days of Brilliance. You see, humans and robots, we share many of the same characteristics. For instance, we both follow instructions. And today's video, we're going to talk about robotic senses. You see, robots and humans aren't really that much different. We have the luxury of having this supercomputer of a human brain on top of our shoulders and inside of our skull. It may be well protected, but that doesn't stop it from receiving and processing all this information like visual stimuli and auditory stimuli and touch sensations. Well, robots don't have the luxury of having this super advanced computer resting in them anywhere. We as humans have to be the ones to interact and teach the robots how to respond properly to stimuli. Since our brain has been adapting to the environments that we put ourselves in since we were born, it has a really good memory and it knows what to do with a lot of the stimuli. So when we sense that there is a danger in front of us or coming up on the horizon, we can react in a timely fashion so we are not put in that danger. A robot, however, doesn't have all of this pre-programmed information unless we teach it about its environment. And that's why today we are talking about robotic senses. For this video, we're going to use our friend, the mBot. You've seen the mBot in many of these videos over the 12 Days of Brilliance. The mBot, out of the box, has 3 sensors. An ultrasonic sensor to sense distance or obstacles, maybe danger up ahead. It has a line-following sensor. And then finally, one of the sensors that's not used often enough is the light sensor on top of the mBot. We've altered this mBot so that it can adapt to its environment a little bit by adding a 7-segment display hooked up to port number 4 on the mBot board so our viewers can have a real-time readout of the information that's coming into the sensors. It's bright, it's dark, it's bright, it's dark. Now you can also do the exact same real-time readout for your sensors on mBlock. If you want to know how to do that, why don't you make your sprite, the panda bear, say something, but rather than saying hello or hi or good to know you, perhaps it could read the real-time readout of the light sensor. If you follow this block of code, it should allow you to do that. Now our mBot has a mission. And that mission is to go out into the world and receive all kinds of information and use its onboard sensors to process that information to ensure it remains safe in its mission to seek out brilliance. Now it needs to make sure that it avoids any cliffs or any obstacles or any dangers that may come in its way. Are you ready? Let's get started. In order to demonstrate the onboard sensors of the mBot, we've written a few different sketches in mBlock, and we'll show you those and how you can recreate this environment for your mBot as we move throughout today's video. First off, those 2 little circles that look a lot like eyes in front of your mBot, this is called an ultrasonic sensor. Remember in the earlier part of this video where we talked about an mBot being a lot like humans? Well, an mBot can be much like a larger part of the animal kingdom. Let's take an animal like the dolphin. A dolphin knows how to navigate its habitat of the ocean by using essentially a sonar within its body to navigate its waters. We learned in science that a dolphin sends out an ultrasonic wave, and when that wave bounces off an obstacle, it comes back to the dolphin, and that time from when it sends it out, bounces off, and receives that signal, the difference in that time allows the dolphin to make decisions based on its environment. The mBot can do exactly the same as long as we program it correctly. Our mBot is on its mission to seek out brilliance. Now, using the ultrasonic sensor, we can already see that the digital readout changes as an obstacle approaches, and it recoils back. So we've written a very simple sketch in mBlock to model this kind of behavior that is saying, get out of the way, there's an obstacle coming. So as soon as I move my hand to grab the mBot, you can see that that ultrasonic sensor is receiving information, and the code is telling that mBot to respond to the environment. Now let's take a little look at the code that you would require in order to make this same function occur in your mBot. It's pretty easy. Here we go. Let's look at the code. We're talking about logic. If an obstacle is detected, then do this. If not, do this. This is a very simple flowchart that is used across different robotic platforms and different computer science applications. For instance, as the rise of automatic and autonomous vehicles occurs, there are all kinds of logic statements that are used within the programming to ensure that the driver and the vehicle remain safe at all times. Essentially, we're doing the exact same thing with our mBot. We start with an event, and then we want this to run in perpetuity, forever, never stop. If the ultrasonic sensor detects that an obstacle is less than 30 centimeters away, then it will run backward or run forward at -100. All other occurrences, so else, it will stop. Let's see if it works. If the ultrasonic sensor senses something less than 30 centimeters, then it recoils. For all other occurrences, for all other events, else, it stops. Now, as our mBot continues on this mission to discover brilliance, I bet it's going to run into other obstacles that it may need to process. What if it detects a cliff? How is it going to manage that? When we're out searching for brilliance, sometimes we run across a cliff. And what do? If we're a robot and we've been told to move forward, I hope that we have been given a command to stop at the cliff, or in our case, well before the cliff, so that we don't fall off. Now, the mBot has a line following sensor that can act as a cliff avoidance system. But in order to use it correctly, we're going to have to use this logic that we've been talking about. If, then, or else. I don't get it. What does that mean? Well, you actually use this every day. For instance, if I brush my teeth, then I will have less cavities. Or else, every other time when I don't brush my teeth, it may lead to cavities. That same logic we are going to use for this mBot. So following along with that logic, if the mBot senses a cliff, then stop. Else, every other time that it doesn't sense the cliff, move forward. Want to see it in action? I'm going to pull up the line following sensor digits here. It's reading 3. When it gets down to 0, it will stop. Uh-oh. 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 And it stopped. Now, let's try that again without me stopping it. Here we go. No hands. Stop. Now, the line following sensor is a really neat piece of electronics. It actually has 2 sets of LEDs in the bottom, and those LEDs are sending out an infrared signal, and it's measuring the amount of reflected infrared light off the surface below. The receiving LED on the bottom of the line following sensor reads the difference every step of the way. And so as that mBot is rolling closer and closer to the edge, it's changing its reading from, yes, there's a lot of reflected light, reflected light, reflected light, reflected light, no reflected lights. And as soon as it senses that difference, it follows the next step in the code. I can't say it stops, because what if I didn't code it to stop? It wouldn't stop. But luckily, our mBot has a code running that tells it to stop. Let's think about that logic statement right now, the if, then, or else. Danger is ahead. Our brilliant seeker is coming upon a dangerous obstacle, and that obstacle is the cliff. Let's make sure that we have coded it properly. So if we sense danger, if there is no floor, then stop. Every other time, it's safe. So already we're starting to talk in the sense of a flow chart. We have options. The goal is to seek out brilliance when it is safe. When we see danger, we must make a choice. We must adapt to our surroundings. And that's what our mBot is doing in very, very simple terms. Here we go. Searching for brilliance. Oh, there's an obstacle. Stop. Every other time, we're going to keep going. We can't stop the search for brilliance. We keep going at a reasonable speed, and then when we sense danger, we stop. So as our mBot is seeking this brilliance, it sometimes may find itself in some shady places. The shady place doesn't have any light. In order to find the brilliance, we need some light. And for that, we're going to look towards the light sensor embedded on the mBot board itself. There's a little diode in the top, and it says light sensor on it. But what happens when the mBot finds itself in the shadiest of places as the numeric display lowers and lowers because the amount of light coming in, and no, the mBot doesn't like it. It wants to look for some light, so it's going to turn around in every direction. It's adapting to its environment, and you can code that using the same logic statement, if, then, or else. Let's go through it with this scenario. What is the if, what is the then, and what is the else? Okay, once again, if the mBot is in the dark, then it will seek out the light by turning in every direction. In every other situation, it's happy. It has light. It doesn't want to change. It doesn't want to move around. It's good. Again, we're using that sequential logic thought in order to solve our problems and adapt to our environments. Are you ready for something really complex? Let's put it all together. Up until now, our obstacles and our dangers have been very simple to avoid, and our mBot has mastered those skills brilliantly. But what happens when there could be a cliff? What happens when there is a cliff and an obstacle coming at it at once, at the same time? Is there a way that we can blend the functionality of both the ultrasonic sensor as well as the line following sensor? So if I don't know, those conditional statements and the logic required uses a lot of brain function, and I need to write that down. And for that, I use a flow chart. Here's our robotic brilliance. Here's our robot. Okay, there are two conditions, really. It's safe, or it's in danger. Oh no, I have to rescue myself. What is that danger? But then there are so many other conditions that we have to talk about. It's a good thing that I put a little work into really mapping this out. Let's take a look at the logic involved in making sure that this mBot avoids a cliff as well as an obstacle. Want to see it work? Check it out. Yeah, just 1 second. So I've taken the time and I've mapped out all of the possible logic statements, those conditional statements, if, then, or else. What you just saw in the video didn't come quickly. It took some serious coding. Like, check this out. Here are all of the blocks that it required in order to make sure that this mBot not only avoided falling off the edge, but it also was able to turn around and avoid any obstacle coming at it as well. And it corrected itself over and over and over again. That's really neat. So as it's seeking out brilliance, it comes across two dangerous situations: a cliff or crashing into an obstacle. So the logic that went into that is really interesting. So if we take a look at where is the if, where is the then, where is the else, it's pretty clear that when the robot is safe, well, that is the only occasion where it's the else. On all other instances, when there is no danger, it has to be safe. So this is the else. When we are safe, we can feel free to move forward. It's when we experience a hazardous situation that we need to employ the if and the then. So here we go. Yes, there is danger, and this is where the if happens. But we've added yet another condition, and that is or. And so the robot may encounter a cliff, or it may encounter a crash, but on either occasion, it is going to make sure that it reverses and turns around. Hopefully there's not another obstacle, but if there is, that's why we've encased all of this in a forever loop. So now we know where our if is. We know where our else is. If danger exists, whether it's a cliff or a crash, then we are going to reverse and turn. But I have a question for you. If you're the mBot, and if you're programming your mBot, or you're programming another type of robot, let's say your own autonomous car, is there one command that takes priority over the other? For instance, which is more important? Is it the cliff or is it the crash? Both are dangerous. But for your mBot, is there more of an immediate concern for the cliff or for the obstacle? And how do you code that within this logical framework of mBlock? Let us know. Let us know, because we're really curious to see the code that you create with all these conditional statements. Thank you very much for joining in on this edition of the 12 Days of Brilliance. Brilliant Labs in honor of the holiday season and this web series, we are issuing a challenge to all of our viewers. If you click on the link below, you will be taken to a form that you can fill out, and upon submission, Brilliant Labs will review it, and then some of our lucky viewers will receive Brilliant Labs support in the new year to complete your project. Check back tomorrow, and best of luck with your Hour of Code initiatives this week. Thank you for tuning in to the 12 Days of Brilliance.